The general form of an exponential function is something of the form f of x equals c a to the x. Note that the variable x here is in the exponent of this expression. Contrast this with the idea of a polynomial or a power function, something like x squared, x to the power 1/2, right? In all of these types of functions, the variable is the base and the exponent is a constant. Here, the base of our exponential expression is a constant. This can also be scaled by a number. So if we have a scaling factor here, that ends up being the y-intercept. We can look at a few examples of exponential data, and in these the y-intercept is really easy to find, right? The y-intercept is always where x is equal to 0, so we can find that right away and see that c in this case is equal to 10. For the base, this is sort of like when we're finding rate of change and interpreting it as slope in a linear function. For the base, we have to look at relationships in the numbers. We can see that between the first 2 points, the y values increase by 5, but in particular they double. So I'm going to say this is multiplied by 2 as we go from 5 to 10. It's important to also note that our x values are increasing by 1. So that we make sure we're looking at the multiplier for every unit increase in x. Again, looking at our y values go from 10 to 20, we could see that they double. From 20 to 40, they double again. And from 40 to 80, they double again, each time for a unit increase in our x values. This tells us that the base, a, of our exponential expression is equal to 2. So the base is the constant multiplier for every unit increase in x. Just from looking at these data, we can tell that this function would be equal to c, which is 10, times our base, which is 2, to the power x. Let's apply that same method to the next set of data. Again, starting by identifying the y-intercept. In this case, we can see that c is equal to 5. And looking at what we would multiply by in our y values for every 1 unit increase in x. In this case, it looks like we're dividing by 3, but since we need a multiplier, I'm going to think of that as multiplication by the fraction 1/3. And then I'll check to make sure that that rule holds throughout the entire table. 5 times 1/3 is 5/3. And 5/3 times 1/3 is 5/9. So we verify that in fact the base in this case, a, is equal to 1/3, and that our function f of x is equal to 5 times 1/3 to the power x. We can also note that where we had a base of 2, we had an increasing exponential function. And where we had a base of 1/3, a fraction smaller than 1, we ended up with a decreasing exponential function. So these can go either way. They can be increasing or decreasing. If we're given 2 points for which the x values do not just differ by 1, then it's a little bit more complicated to figure out what our y-intercept and our base are. There are a few ways that we can approach this. One way would be to set up a table with x and f of x and just try to fill in the missing values and see if we can figure out the rule. So if we start from -1, then go up to 0, and then 1 and 2, we need our x values to be spaced by 1 to find a, because it's the constant multiplier for each 1 unit increase in x. At x equals -1, we have a y value of 1/8, and at x equals 2, we have a y value of 8. So we could try guessing the numbers in between. For example, I might say, okay, maybe it doubles at each step. If it doubles at each step, then this would be 1/4, and then 1/2, and then I would be up to 1. So it looks like it's something bigger than that, and I can try guessing again. So now maybe I'll say, let's suppose that it grows by a factor of 4 at each step. That looks plausible. With numbers like 1/8 and 8, it does seem like it's probably a power of 2. I'm not going to try something like 3, right? So let's guess that maybe my base is 4, which would mean multiplying by 4 at each step. That would get me 1/2. 1/2 times 4 is 2, and 2 times 4 is 8. So I was able to figure out the base just by going with what it looked like it might be, filling in the numbers in between, and verifying that multiplication by 4 at each step would get me from the first point I was given to the second point I was given with an exponential progression. So I would call this then f of x is equal to 5 times 4 to the x. Sorry about that. I was looking at the last example for a second there. This c for this problem is equal to 1/2. So I'm going to put in 1/2 times 4 to the x. There are ways to do this algebraically without guessing the numbers. We can set up 2 equations in 2 unknowns if we want to also. So let's take a look at another way to do this. Another way is to say I'm going to take the relationship f of x equals ca to the x and plug in these values that were given for the 2 ordered pairs to get 2 equations. So looking first at f of 2 equals 8, that tells me that x is equal to 2 and f of x is equal to 8. So I'm going to write that as 8 equals c times a to the power 2. Then looking at this second ordered pair, this tells me x is -1 where f of x is 1/8. I'm going to write that as 1/8 equals c times a to the power -1. Now what I need to do is use something like the substitution method to go from one of these equations into the other. It's usually easiest to start by solving one of the equations for c. So to do this, I'm going to multiply both sides by a to the +1 and get that a over 8 is equal to c. Then I'm going to take this a over 8 and plug it in for c in the other equation. So let's bring this over here and write it as 8 equals a over 8 times a squared. Now I'm going to write this, combining the a's, write this as 8 equals a cubed over 8. And then multiply both sides by 8. So that it will cancel from the denominator here and give me 64 equals a cubed. Then taking the cube root of both sides, I just want to recognize what number I would raise to the third power to get 64, and I can see that I also get a equals 4 doing this. So there's a strictly algebraic approach that will find the same a that I found by guessing how to fill in the numbers in between. Finding C and A from a graph is really no different from finding C and A from a table of numbers. I just want to identify some points that are separated only by 1 unit in x. I can either actually write a table of values for it, or I can try to just figure it out logically from the graph. So if I write out these ordered pairs, I have -1, 4, 0, 2, 1, 1, and I'm going to guess 1 and 1/2, but maybe that 1/2 is a guess for now until I've established A and can verify that I have it right. Sorry, that's x equals 2 and 1/2. So my x values are spaced 1 unit apart, and I can see that I would multiply by 1/2 for my y values. So now I can see that that guess of 1/2 was correct, that in fact this is 1/2 and not some other fraction. I can also see that my y-intercept is equal to 2, and therefore I can conclude that this function would equal 2 times 1/2 to the x. I can do this from the graph without actually writing up a table of numbers if I'm willing to just examine, as I increase 1 unit in x, what do my y values multiply by? And in this case I can see that it is a decreasing function. The fact that it's decreasing tells me that my base has to be a fraction between 0 and 1. So I'm looking for a fraction that I would multiply by for this 1 unit increase in x. I'm looking right now at the step from -1 to 0. And we only need to look at 2 points. We only need to look at one step to figure it out. We can look at more steps just to check and make sure we got it right. But measuring this amount and this amount as being the same tells me that I cut in half, right? Multiply the y values by 1/2. For each unit increase in x. So it's the exact same analysis that I do from the table. I'm just looking for it in the graph values rather than looking for it in a table of numbers. Gets sort of messy trying to draw notes on here, right? But also as we go from 0 to 1, I can see that my y values decreased from 2 to 1, right? So I can see that I have the same pattern going on here, right? Same. It also multiplied y by 1/2 for the next unit increase in x. So this is another way that I can see that my base is equal to 1/2.